Welcome back to The Explainer. Okay, I want you to picture this. You're sitting right there in the pilot's seat of a small aircraft. Outside your window, it is literally pitch black. The world has just been swallowed up by darkness. Below you, those familiar shapes of cities and fields are completely gone. They've been replaced by this single, sparse, glowing ribbon of ground flares marking a runway. Today, we're putting you in that left seat. We're going to break down the exact step-by-step procedures that pilots use to conquer the midnight circuit. Let's get into it.
Think about the intense focus required to guide a fast-moving machine down out of the night sky when all your normal visual cues are just stripped away. Seriously, what does it actually take to safely bring an aircraft down to the tarmac using little more than a path of flares and a rigid set of procedures? Well, it takes a flawless marriage of mechanical precision and absolute sensory awareness.
So here's our literal flight plan for today's explainer. We're going to navigate the midnight circuit, run through the mandatory bumfish checks, execute the ideal approach, make our touchdown in the dark, and finally look at landing with lights.
All right, Section 1, Navigating the Midnight Circuit. Now, the very first thing you've got to understand about flying at night is that all approaches are engine-assisted. But structurally speaking, the actual circuit pattern you fly around the airfield, it remains exactly the same as it does during the day. You're just flying it without the benefit of a visible horizon, which is wild to think about. So, flying parallel to the runway on what we call the downwind leg, I want you to look out your virtual cockpit window to your left. Your primary visual marker in that abyss is the flare path on the ground. To know you're perfectly positioned on this downwind leg, you need to see your wingtip visually trailing right along that line of flares. If it's tracking perfectly, you are right where you need to be.
Moving on to Section 2, Bumfish Pre-Landing Checks.
But hold on, you can't just turn toward the runway yet. The tension is kind of building here because before any descent begins, you have to execute a really rigorous, non-negotiable routine. Enter Boomfish. Yeah, I know it sounds a bit clunky, right? Maybe even a little silly. But this bizarre-sounding acronym is absolutely crucial. It's the high-stakes protocol that literally keeps pilots alive in the dark. It's a systematic checklist performed right there on the downwind leg to make sure the aircraft is mechanically prepped for the descent, way before the pilot's workload gets too heavy.
As the pilot, you're rattling through these with intense focus. You check B for brake pressure, U for undercarriage, making sure it's down and locked, or just noting it's fixed like you'd find in a Cessna 172. M, your mixture is set to rich and the aerator is 0 or positive. F, fuel selector valve is on both and the shutoff valve is on. I, ignition's on both, with engine temperature and pressures in the green. S, security, meaning seatbelts are completely fastened and there are 0 loose articles flying around that dark cockpit. And finally, H, height, confirming you are holding the exact, correct circuit altitude.
Next up, Section 3, Executing the Ideal Approach.
Okay, so with the bumfish checks perfectly executed and the downwind radio call made right in line with the beginning of the flare path, the prep is done. Let's see how this builds and break down the spatial geometry of actually turning a plane in the dark. You're watching that flare path closely. When it appears at precisely your 7 o'clock position, you commence your turn to the base leg, checking your instruments to make sure the turn is correct. Using your directional gyro indicator, you roll out to fly exactly 90 degrees to the flare path. Now here's the tricky part. At night, sensory deprivation creates a really dangerous tendency to turn late onto your final approach, so you have to wait until the beginning of the flare path reaches exactly your 9 o'clock position to commence that final turn. That keeps you from making a dangerous overturn in the dark. While you're navigating those precise angles on the base leg, your hands are super busy making critical, multitasking mechanical adjustments. You're pulling back the throttle. You're deploying your flaps to the recommended setting, which is 20 degrees. And you're trimming the aircraft to stabilize your speed at exactly 70 knots. Then, you just roll out seamlessly onto the extended runway centerline, completely ready for an engine-assisted approach.
This part brilliantly illustrates the level of delicate micromanagement required. You've given your radio call. You're looking at the perspective of the flare path. As you get closer and closer to the ground, that perspective naturally begins to change. You have to maintain the ideal visual perspective and gently adjust your throttle to commence what's called the round-off. Basically, that means leveling the plane out, and you do this precisely between the first and second ground flare. It's this incredibly delicate, fluid motion of gradually flying level and gently closing the throttle.
That brings us to Section 4, Touchdown in the Dark.
This right here is the moment of truth. You're mere feet above the runway now, controlling your sink rate purely by changing the attitude of the aircraft. The absolute most crucial point is how the aircraft actually meets the tarmac. You're pulling the control column backward progressively. You want to feel the main wheels touch down first. The moment you feel that solid contact, you don't shove the nose down. No way. Instead, you gently release that back pressure on the control column, allowing the nose wheel to just settle and touch down completely naturally.
But hey, the job isn't over just because the wheels are down. You're still rolling fast in the dark. To maintain your direction, you got to make sure that sets of flares are passing simultaneously on either side of the nose. It's like flying through an intense visual tunnel. As the aircraft finally decelerates to taxiing speed, you're actively scanning the dark for a very specific signal: double flares. Those double flares are your safe exit path. You follow them to clear off the runway, follow the taxiway lines, and stop to carry out your after-landing checks.
Finally, Section 5, Landing with Lights.
Now, what's really interesting about this is everything we just discussed was the ideal approach, relying completely on those ground flares. But there is an alternative method: landing with your aircraft's landing lights on. However, before we even look at the mechanics of this, we have to establish an absolute, non-negotiable safety boundary. Using your landing lights is strictly forbidden in rain or bad visibility. Why? Well, because those bright beams will hit the moisture or fog in the air and reflect straight back into the cockpit, instantly blinding the pilot in an already high-stress environment. Obviously, we don't want that.
Let's juxtapose these two methods side by side. In the ideal dark approach, you rely purely on the flare path, allowing your eyes to maintain a consistent dark adaptation. But the landing lights approach introduces some severe visual illusions. Because the powerful lights suddenly blast the ground with illumination, pilots suffer from a very dangerous tendency to round off too high. They basically think the ground is way closer than it actually is. To combat this, you are explicitly trained not to look directly into the beam of your own light, but to look slightly to one side of it. That helps maintain your proper depth perception.
And you don't just leave these lights on for the whole circuit either. If you are going to use them, the procedure dictates that you flip that switch at exactly 300 feet above ground level, or AGL, on your final approach. From there, the mechanics of rounding off, controlling the sync, and touching the main wheels down first remain exactly the same.
But the landing lights approach features one of the most disorienting sensory shifts in all of aviation. Once you've landed and slowed to taxiing speed, you must switch the landing light off. Going from a brightly illuminated runway back to sudden, absolute pitch-black darkness is a massive shock to your eyes. In fact, the source text explicitly warns pilots to watch the direction during the sudden darkness as they transition back to relying solely on those faint ground flares to find the taxiway. It's an incredible display of skill, isn't it? The precise timing, the battle against visual illusions, the rigorous safety checks in the pitch-black night. It's like a giant puzzle. Next time you're a passenger on a night flight, peering out the window into the darkness, I hope you'll think about the silent, intricate dance happening right up there in the cockpit. So, will you recognize the hidden midnight circuit below you? I bet you will. Thanks for joining me on this explainer, and keep your eyes on the skies.